Hello, Assalamualaikum. Today we are studying here for inter first lecture, chapter number one, kinetic molecular theory of gases. This is first lecture of intermediate class, and I think you must understand this lecture. And lot of MCQs you will be seen in this type of the temperature. Temperature is your first topic. And what is temperature? You must know about temperature. Temperature is the degree of hotness and coldness is called temperature, and this is also called zeroth law of thermodynamics. This is the definition of zeroth law of thermodynamics. You must know that there are four laws of thermodynamics. First one is zeroth law of thermodynamics that discussed about temperature, and first law of thermodynamics they discussed about internal energy and energy conversion, and second law of thermodynamics that can be show the entropy and process of entropy or directions of entropy, and third law of thermodynamics also discuss the absolute temperature can be reached. Now you must know the degree of hotness. You must know that how hotness is come. Hotness is come when bodies absorb the heat. Bodies absorb the heat. When bodies absorb the heat, they get a hotness. When body absorbs the heat, this condition is called heat capacity. This condition is called heat capacity. When our body absorbs heat, this condition is called heat capacity. But when our body store this heat, this is called thermal conductivity. We can say that this is thermal conductivity. And you must know that when hotness come in our body, the gases can be expand. Suppose in terms of gases, we can discuss this. The gases can be expand due to hotness. When gases expand, volume increase, temperature also increase, and this condition may be at constant pressure when pressure is constant. And also hotness comes from any source, then we can say that work is positive, work is done by the system. And also we must know that how coldness come. Coldness is come when we reject heat. It means when we reject heat, the body will be in coldness when we reject it. When we reject it, when bodies are compresses, when bodies compresses, they reject heat. This is coldness. This term is called coldness. When coldness comes in gases, work is done on the system and work will be negative. This is first definition of temperature. Degree of hotness and coldness is called temperature. Second point is temperature is macroscopic concept. Why we say temperature is a macroscopic concept? Because temperature is a microscope. The body is concerned with large velocities. This is macroscopic concept, and temperature is also macroscopic concept. And you must know that temperature is a property of state and state variable, because temperature is a final and initial position T1 and T2. A body have a final and initial position. It is a macroscopic concept. And also we know that the bodies are microscopic concept. So suppose speed is microscopic concept, kinetic energy is microscopic concept. These are microscopic concept. And other one is science for measuring. That science that measure the temperature, that science is called thermometry. Thermometry means the measurement for science of temperature is called thermometry. And the substances, there are many substances. We have a liquid, we have a gases, we have a solid. Many substances when changes uniformly gradually after heating, this is called thermometric substances. We have an example of mercury. Mercury is a thermometric substance. Mercury is a good conductor of heat, and mercury have a low specific heat capacity, and mercury have a high thermal conductivity. And you must know that the doctors also in doctor thermometer we use mercury, because mercury freezing point is minus 39 centigrade and boiling point is 360. This way doctors use also thermometric substance as a mercury. Next point is it depends upon average energy. We know that heat is the total energy. Heat depends upon total energy. Total energy means heat depends upon kinetic and potential energy of the molecule, but temperature depends upon average. It means average means when we heat someone, when we heat a water, the molecules are some molecules are moving very fast, after heating, and some molecules are moving very slow. Due to slow and fastness movement of molecule, we can find here average energy of the molecule, that may be kinetic and potential energy of the molecule. But in ideal gases, we only learn about kinetic energy, but real gases we have a kinetic energy and maybe potential energy. Now we come to scales of temperature. For scales, before teaching scales of temperature, we have an example of thermometer. Thermometer have a 2 point. First one is LFP, that is called melting point. Melting point, and other one is UFP, that is called boiling point. In thermometer, there are 2 point, LFP and UFP. The difference between these two scales is called scale of graduation. Now we have come to centigrade scale. This is centigrade thermometer. Centigrade is a Celsius is an astronomer that make a thermometer. This is known as centigrade thermometer. In centigrade thermometer, LFP lower fixed point is 0 centigrade and UFP is 100 centigrade. If we go lower than 0 centigrade, this may be a not a melting point. This may be a freezing point of anything, because when we go behind the 0 centigrade, this may be a freezing point, and in 0 centigrade, this may be a melting point. And next one is NHB. NHB means normal human body temperature. Normal human body temperature in Celsius is 37 centigrade, and absolute zero. You must know that absolute zero is that temperature in which volume and pressure of gases will be zero, and maybe all liquid, maybe gas may become a gases. This temperature is called absolute zero. In Celsius is minus 273 centigrade, and this is a formula also we use in problems to solve the centigrade scale problem. Now next one is Fahrenheit scale. Also medical doctor uses Fahrenheit scale thermometer. In Fahrenheit we must know that also use a mercury. I have told about this one. LFP of mercury thermometer, Fahrenheit thermometer is 32 Fahrenheit, and UFP upper fixed point is 212 Fahrenheit. You must know that LFP will be melting point and UFP will be boiling point. NHB means normal human body temperature. In Fahrenheit scale is 98.6 Fahrenheit, and absolute zero is minus 460 Fahrenheit. And also TC and TF meet. It means Celsius scale and Fahrenheit scale meet at one point, that will be minus 40 degree. Minus 40 degree, TC and TF will be coincide. And also the ratio between TF and TC will be equal to 1.8. This is the ratio of TF and TC, and this is the formula. In this formula we can solve the Fahrenheit problem. Now we go to third scale. That one is Kelvin scale, that never be negative, and Kelvin scale also known as a thermodynamic scale, because in this scale we can find the triple point of water. Also you must know that what is triple point of water. In what the scale, the curve in which all matter states can be meet, this one will be triple point of water. It means in in solid we can see ice, in liquid we can see water, in gases we can see water vapors. This is thermodynamic scale, and also LFP of this one is 273, UFP is 373, and the difference between scale is 100. That must be know that. And NHB normal human body temperature is 310 Kelvin. You can also find this 301 Kelvin from this formula, because you have know that TC is 37. 37 plus 273 is equal to 310 Kelvin. This can be known from this formula. And absolute zero in Kelvin scale is 0 Kelvin. This is the absolute zero. You must know that a semiconductor may be an insulator at this 0 Kelvin. And these are the topics that we can discuss today, that are belong to first chapter kinetic molecular theory, and topic will be temperature and scales of temperature. You must understand that. If you have any question, then comments, and also like and subscribe my channel. Okay, Khuda Hafiz.